Hello friends, happy Independence Day. We are back. We Code Warriors are back with our new workshop, MLOps. And for such workshop, you can go and visit our website codewarriors.in. So here is today's event, MLOps, and our speaker is Saurabh Yadav. So little introduction about him. So Saurabh Yadav is a senior machine learning engineer at Fractal Analytics. He had completed his bachelor from in computer engineering from NIIT University. He has also done research as a research assistant at his university. He is a cloud and Kubernetes expert. So at the end of this session, we will have a Q&A session, and after that, our support team will provide the link for the certificates in the live chat and description of this video, and you can fill the form till 12 a.m. So let's hand over to our speaker Saurabh Yadav.
Hello everyone. Thank you, Snehal, for the introduction. I'm Saurabh Yadav, and I'll be doing this session on this topic called MLOps. I'll jump right in. So, I'm Saurabh Yadav, and I'm a machine learning engineer at a company called Fractal Analytics. So I'll start with my experience so far, basically a quick history of the type of work that I've been a part of. So I've worked in mainly worked around the AI industry, the AI domain, starting with computer vision. As Snehal mentioned, I worked as a research assistant in my college on a project related to computer vision. And then also worked in IoT, DevOps, data engineering, mainly focused around cloud computing, which included architecting solutions around building machine learning and AI applications. So using that, the main field around that whole domain is machine learning engineering. So I'm currently working as a machine learning engineer. So quickly go through the topics that we'll be covering in this session. First one is I'll give a brief introduction about machine learning as a whole, AI, and then the DevOps. After that, I'll be starting with a deep dive into what machine learning engineering is, along with MLOps. And then I'll also talk about the current state of MLOps, as in how you can learn about MLOps, what are the exact things that you need to focus upon when you talk about MLOps. So before we start the talking deep dive, I would like to start with this quote from 𝗗𝗔𝗧𝗘. So he says that AI is the new electricity. Just the way that electricity transformed almost everything 100 years ago, today it is hard to think of an industry that AI will not transform in next several years. So he's comparing AI to electricity, like the way electricity transformed transportation, healthcare, and everything else that we use is heavily impacted by electricity. So just like that, his predictions, or it's the prediction of many great minds, that AI will be the new electricity. It will transform almost every industry in the next several years. All right, so I'll quickly start with setting up the context, basically giving you the examples of like the day-to-day basis uses of AI, artificial intelligence. So you must have seen there's a lot of talk about we're using artificial intelligence in self-driving cars. So companies like Waymo are leading the industry in that domain. Then we use, on a day-to-day basis, we use Google Assistant. So there's an NLP engine that is behind the scenes making all that happen. right? And we also see it when we buy something from Amazon. So we get product recommendations, you may also like, or you can buy these things together. So there is a recommendation system that is behind the scenes, which is an AI. Then we almost everybody nowadays, every phone has this facial unlock. So there's a facial recognition technology that is behind the scenes, which is an AI. If I talk about that, and yeah, so just before that, so all of these applications have one thing in common when we talk about building these AI systems. So there's a machine learning model, or there's a machine that is like trying to learn. So to make those application, to make that machine learn, there's a proper life cycle that goes behind the scenes. So I'll talk about that. We call it machine learning life cycle. So it's a very, very high level. There is a lot other than these three steps that goes behind the scenes. But to like keep it very, very simple, I've categorized or made these three steps. If I talk about the first one, data preparation. So it's the data that the machine is getting trained on. So let's say I give you an example of facial recognition. So if I want that system to recognize me and my friends, then I'll have to give the machine or tell the machine that how do I look and my friend looks, so that it can learn on my facial features, or whatever that is there in that image, to separate out or differentiate between me and my friend, and tag exactly that, okay, this is Saurabh and that is other guy. So to capture that data, we need we have this step called data preparation. We in this we have multiple steps. We gather the data, as I've mentioned in the example of facial recognition. We give a machine some data, and before giving it to the algorithm that is learning, we clean it, we transform it in a way that the computer can understand, or that machine learning algorithm can understand and learn from. So we transform the data. So that's about data preparation. Then we go to the step called model training. So most of the machine learning algorithms spit out a neural network that is trained. So we call it as a model, machine learning model. So that's basically a neural network which we feed these images or some data to the neural network, and it trains, and then we get a trained model which we can further use to give it some new data and get out the prediction. So and that is we have to do the deployment of that model in order to properly utilize the trained model. So that's about it. I mean, on a very high level, that's the whole machine learning lifecycle. We prepare the data, we train the model, and we deploy it in order to efficiently utilize that model. So this is a great example or a great illustration from Google Cloud team, where they get you to the gravity of what are the different things that that a AI system consists of. So in the market, like everybody talks about machine learning, the AI, the ML code that is there. Everybody talks about algorithms like regression, all the neural networks and everything. But that's not all that goes into that building that AI system. So if you can see, there's a dark rectangle in the middle that says ML code. That's that small. Like everything that is around it also plays a very, very important role in order to make that AI system work. So you can see something called data collection, which I talked about. Then we also have to verify that data. We have to analyze that data before we give it to a code that is getting trained on it. We do some feature extraction. Then after training that whole model, we have to deploy it. So we call it model serving. So we need a serving infrastructure for that. That's also a part that also plays a big part when we talk about productionizing those machine learning systems, right? And when we put those machine learning system in production, then we also need to monitor them, because it's very different from traditional softwares, traditional applications, where we just write the code as in what should happen when I click on this button. So those rules are set. But in terms of and in case of machine learning, it's not like that. It's not that straightforward, because there are a lot of real world data that is coming in, on which that model needs to perform well, and that performance of that machine learning system might degrade. So we have to constantly monitor that whole machine learning system. So this slide is basically telling that there are multiple things that we need to take care in case we need to productionize or put that machine learning system, or in common terminology we call it AI systems, to work, right? We have to take care about for all this. And in order to manage each and every little piece that goes behind the scenes, so in case of as I talked about, in case of traditional systems, like I'll give you an example of a mobile application, right? So we have mobile application like WhatsApp we have. So WhatsApp, the whole life cycle, if I may try to put it, the whole life cycle would be that the developers are writing the code for that application, then that code is getting packaged, and then it goes to the Play Store and you download it from there. But that's just a one-time thing. But normally in real world, it doesn't work like that. There are consistent improvements over time on that application. There are new features that are getting added. There are bug fixes, and all the iterative process that goes behind the scenes constantly, right? So to manage that constant life cycle, to manage that iterative process, we have a traditional system or concept called DevOps. So it takes care of all the automation, all the automated testing of the code before we release it, and the infrastructure needs, and the connection from the developer to the code repository and to the app store. Everything needs to be in an automated fashion, so that we don't get exhausted repeating those that process again and again. So that's for traditional systems. But I'll quickly talk about what is DevOps and how is MLOps different from it. So as I talked about, in case of a traditional application, we have the two loops that are on the right hand side, the dev and the ops. In dev, as I mentioned, we create that application. First, we plan that application, what needs to go in. We create that application. We verify that whatever we have created is right or not. Is it proper to go into production or on the app store? In case of an mobile application, we package it. We package it in a way that it is uploadable on the app store, or and in case of machine learning systems, we package the code so that it can run on the cloud. It can take new data and give out the prediction in a proper way. So we package that application. Then in the ops loop, we release that application. We release it on the app store in case of mobile application. We configure it, and then we monitor it, whether it's performing right or not. So all the app crash reports that your mobile sends to the developer, that's basically an active monitoring tool that is put in place so that the developers can improve that application over time. So that's done through monitoring. So that's all about a traditional application. But in case of a machine learning system, we have this ML loop as well. So as I talked about, let's say a facial recognition system, right? So we do it initially, let's say, in case of an organization, if they want to, let's say, build an attendance system using facial recognition, so that ML system would need to get all the data to train upon, right? So all the employees that are there at that particular time, if let's say the organization has 10 employees, then we'll get the data for 10 employees. And when I say data, it's the images in terms of facial recognition. We get those facial images. Then it's just one time we put that system in production, it works fine. Any person comes in front of that camera, it recognizes it, marks the attendance, and then that loop continues. But in case we need to add more data, there's a new employee that has come in, right? And we need to train the model on top of that employee's data as well, so that there's a loop that gets created, in which we need to, let's say, add some data to the model, train the model on the new data, and also remove the redundant part. Let's say if an employee leaves, then we need to remove his data from the system, so that the model doesn't recognize that person after he leaves. So there's a loop, continuous learning loop, that needs to happen in case of ML systems. Other than that, all the dev and the ops side goes with it. And that's why we take heavy inspiration in terms of MLOps. We take heavy inspiration from the patterns and processes that are set up using DevOps as well. That's why it's called MLOps. DevOps, including the machine learning or that continual learning loop as well, right? Okay, so I talked about this, but these are the three main parts that whole system has. There's continuous integration. So let's say if there's a new feature that is being added to the application, then we develop it, then we package it. So it's the continuous integration loop. And then we have this continuous deployment. So it doesn't count to add a new feature until and unless we deploy it. So there should be a pipeline to deploy those changes continuously without any manual intervention. The more the automation, the easier it is for the developer or the manager who is managing that development lifecycle, right? And so the CI and CD typically goes into that DevOps part. But in terms of MLOps, this one more concept that is added is continuous training. So in any I gave you an example of facial recognition, that attendance system, but there are multiple, like in almost every machine learning system, it needs to improve. It needs to improve over time, and the way it does is get more data, do the training process again, and continue that loop over time in order to improve that machine learning system. So there is a continuous training loop that goes behind the scenes, right? And all of this pipelining, this automation, handling that process from end to end, that's what, like if I put it simply, that's what MLOps is, right? So if I talk about the current state of MLOps, and when I say current state of MLOps, it's mainly to deep dive into what exactly goes behind the scenes in MLOps. What are the tools and technologies that we use? What are the different key areas on which that MLOps framework is being built? So I'll quickly go through all the tools available and and relating it to all the concept that MLOps consists of. So if I continue, yeah. So mainly, as I also talked about in the previous slides, there is data and there is a training loop, the training or evaluation, and there is the deployment part. So I'll quickly go through these tools and frameworks that are currently being used in order to accomplish all these steps in that machine learning lifecycle. So if I talk about data, it's not only about data storage, it's about processing that data, managing that data. In order to manage that data, we might also have to version that data, right? And in order to make the machine learning model understand that data, we need to label that data. So it's a subset of machine learning, which is called supervised learning. Most of the machine learning applications that you see, or which I talked about in the previous slides, works upon that supervised learning concept, which requires the data to be labeled in order for that machine learning model to understand the data and to learn from it. So there is that labeling. There are tools like Scale, Aquarium, which are used on scale to label the data. For versioning, there's a famous framework called DVC. It's data version control, and there is an enterprise software as well, which is called Pachyderm, which mainly deals with making data pipelines. When new data is fed, that automatic versioning of it, the management of it, the accessibility of the data to the developers and everything, that is handled through Pachyderm. After the data is gathered and versioned and labeled, we need to pre-process or process that data. So we do some cleaning, like all the unnecessary data. That is, like if we get raw data, we need to remove all the irrelevant data or rows or columns, or whatever part of data, in order to like make it ready for ingestion for that machine learning model. So we do pre-processing, and to do that there are multiple tools like Apache Spark, which takes care of handling the data on a large scale. So it's not only about small incremental changes. There are machine learning systems which require entire a huge data set to retrain the whole machine learning model. So to handle or to process the data at scale, we use tools like Apache Spark. We use pipelining tools like Apache Airflow and Dagster and all the other things. So that's about pre-processing. And before even pre-processing, we do some exploration. So when, like, how do we know what data is right or wrong? There can be automated tests, there can be automated validation that we put in place, but there is some manual intervention that happens like right now. So we do some data exploration. There is a famous Python library called Pandas to explore that data, to look at that data. What is the variance in that data? What are the columns that are required? How can we manipulate those columns and everything? So we have multiple tools for data exploration. For storage, it's a very well matured field. It existed even before machine learning came into picture. So we have Amazon, AWS, Azure, Amazon's AWS, GCP, Azure. These cloud providers provide data storage solutions. Like you must have heard of S3 buckets on AWS. You must have heard of Azure Blob on Azure, and all the different companies like Databricks, Snowflake. They provide these storage solutions. And also there are multiple sources which highly correlates with that storage part. So I won't talk about that. These are S3, some databases like Postgre, and different file formats like Parquet and everything else. So that's about data. We mainly source that data, we store that data, we version that data, we label, pre-process. Along with that, we might also have to do some exploration. So these are the common tools that are used to do everything related to data. Then we come to the training part. In training, it's not only about writing a machine learning code, giving it some data, and just getting out the trained model. There is a lot more than that goes behind the scenes. We need to take care about the compute or the infrastructure that machine learning training needs to happen upon. So we have most of you guys have heard about Google Collaboratory. So it's for experimentation, right? It's not a productionizable infrastructure, if I can say. So most of the cloud providers provide this compute infrastructure in different ways. We have managed Kubernetes services. So it's a framework to run all the training, the data preprocessing and everything. So that's compute. Majorly cloud providers provide that. So Lambda, AWS, Azure, all of these cloud providers provide that compute hardware to run that machine learning model upon. And these cloud models can provide that compute infrastructure, but to manage it or to configure it, personalize it according to our own needs, according to our own pipelines, our own application, we have different frameworks to manage those resources. So these are compute resources, these are storage resources, memory resources, and everything else. So if you want to properly manage those, there are frameworks like Kubeflow, Docker containers, and everything to manage that resource, to modify it according to our own needs, our own machine learning pipelines. To write the code, as you guys should know, there is Python, there is VS Code, Jupyter Notebook to do all these initial level dev level work to make those machine learning algorithms so that they can be trained upon. Before making a specific pipeline for that machine learning development, we need to experiment. Let's say in case of that facial recognition system, we need to experiment first that which machine learning model works, right? Or which machine learning model, which algorithm gives you more accuracy. There are, in terms of deployment, there can be hardware limitations in order to run that model. So which model performs better, takes much less compute to run. So all these experimentation are done in almost every machine learning development. So to structure that, to make it as a standard, there are multiple frameworks that use to manage those experiments and compare them after we have done those experiments. Open source tools like MLflow, weights and biases, TensorBoard. So the community that built TensorFlow provides this framework to manage the experiments that we do with TensorFlow. It's called TensorBoard. So there we can track the model accuracy, its performance, and all the other metrics that we want to track, and then later on compare it with each other, and then select the best model to build a pipeline upon to productionize it. In terms of training, there is a specific thing called hyperparameter tuning. So how we can experiment with that accuracy is to tune some matrices or some parameters, like what number of layers in that neural network I want to put in order to achieve maximum accuracy. There are multiple hyperparameters like that, which we need to tune in order to get best performance. So for hyperparameter tuning, there are multiple frameworks. As I mentioned, weights and biases, it provides automated hyperparameter tuning. You provide the parameters which can improve the accuracy, and it will create its own system to check what parameter, what value of those parameters is giving the better performance. We can also put in what performance that we need to track. What do we mean when we say a better performance? Is it just the accuracy or the compute power that it is taking in order to do that prediction, right? So we have multiple frameworks for that. We manage, we have the compute resources, we manage those resources, and then when we do training, so there is a lot of potential that we are not doing the training in a right way. We are not utilizing that resource or that compute resource, compute infrastructure in a right way. So there are multiple frameworks in order to distribute that training over multiple machines in order to achieve that less training time and like whatnot, to utilize the hardware efficiently. So there is fast AI, there is Ray in order to manage the distributed data processing, and this is Hugging Face, TensorFlow. So all of these predefined libraries as well provides you the parallelization of the training process. So that's about the training part, right? There are multiple frameworks for multiple parts of that whole training step, right? It's not only about writing a code, giving it data, and like getting the model out. All of these different sections are there that needs to be managed in order to simplify that whole process, right? So when we have like processed the data, took care of the data that is coming in, we pre-process, version it, and then we train train the machine learning model, do experimentation, do hyperparameter tuning, do the distributed training, and everything else. Then we get out a machine learning model or an algorithm that is able to take new data and give out the predictions. So in order to utilize that, there are multiple challenges to do that. So it's not only about writing the code in Python and then utilizing the model in Python only. We might have to put it on a mobile application. We might have to put it on a cloud server. So I'll give you an example. In let's say in a manufacturing industry, right? There is a manufacturing line where there is no computer that is there, but we need to let's say put a camera and a machine learning model there to detect defects in whatever parts that are getting produced. So we need to run that model alongside with that camera, where there is no cloud, where there is no server that is put in there. So there are edge devices, or we call it system on chips. You must have heard about Raspberry Pi, right? NVIDIA Jetson Nano, or like system on chips like that, right? So to make those machine learning models run upon these different hardwares, different operating systems, different infrastructure, we need to convert them, we need to optimize those models. So in terms of deployment, there are a lot of challenges. It's not that straightforward because there are a lot of frameworks, a lot of operating system that that model can run upon. So we might use some web-based infrastructure to manage that. We use frameworks like Selden, which deploys the machine learning model, and in terms of an API on which we can send the data and get the results out, right? And if that utilizing of that model is taking a lot of compute itself, then we use tools like, or frameworks like Kubernetes in order to parallelize that inference part as well. So in terms of let's say if I take an example of a complex application like Amazon, right? If we so there is no one person that is buying anything and getting the recommendations out. There are multiple millions of people that are using that AWS, but let's say there is one single model that is being trained, or there are multiple models for multiple people in order to personalize those recommendations. So in order to serve those models or put those model in production, there needs to be infrastructure that can handle all these models, all these requests of generating all these recommendations. So we use frameworks like Kubernetes. AWS SageMaker is a great tool in order to deploy the models as well. And there is a whole domain called edge computing or edge AI. So NVIDIA has built a great tool called NVIDIA TensorRT. TensorFlow has created its own version of TensorFlow in order to run it on edge devices. And when I say edge devices, it can be your mobile phone, it can be a system on chip that I talked about in case of manufacturing industries, or whatever industries, that small little chip that runs that whole algorithm. So TensorFlow Lite is one, Onyx, and all the other frameworks that are used to make that model run upon edge devices or devices with lower compute power, right? Without any, let's say, connectivity to the internet or something, right? And yeah, I think that's about deployment part. Everything I think we have covered, from data to training to deployment. There are multiple steps that are involved, and there is a framework for everything, and there are multiple frameworks to accomplish each and every step in this whole life cycle, right? So I think, yeah, that was about the introduction, or what you need to know about MLOps, right? And to summarize it all, I think in order to create an AI system, a machine learning system, the difference when we create a traditional application, if I compare it to the AI systems, is that we need some standard process management framework, and that framework or that concept in case of traditional applications is DevOps, which automates, manages, optimizes that whole process from developing a new feature, developing an application, till it is being deployed into real world. And like the whole loop, we deploy it to the real world, we monitor it, we take the customer feedback, we create new features, and then we package the code, test it, run it, and then deploy it, right? So that's the whole process. So in order to manage that, there is a concept called DevOps, which includes multiple steps, managing of multiple steps, automating multiple steps. In case of AI systems, everything that I talked about DevOps, including the machine learning loop, that continuous learning loop that is also there, which requires continuous ingestion of data, retraining of the machine learning system, that machine learning model, and redeploying it in order to serve it to the existing application, right? Where it can make give the machine learning model some data and get out the prediction, right? So along with DevOps, this continuous training loop, managing that whole thing, is the whole concept of DevOps. I also talked about all the different little steps or parts of that whole life cycle, specifically talking about that machine learning system, all the tools and frameworks, the different steps and sub steps that goes into it, right? So uh, like in order to learn about this field called MLOps, there are multiple resources. If you Google about it, you'll find thousands of resources, thousands of articles and online courses and YouTube videos to learn about it. Just the condition is that you have curiosity to learn about it. So my recommendations, or what I use to learn about this field, I'm sharing it with you. So there are multiple courses on this website called fullstackdeeplearning.com. So great universities which teach this field puts their courses on for free on fullstackdeeplearning.com. You can visit that. I know that this is a new field, a relatively new field. So most of the colleges in India or even abroad have not adapted to or included some courses related to this particular field. But there are some good universities which provides these courses, and it's a good website if you want to go to that, fullstackdeeplearning.com. This is also a good book by 𝗙𝗔𝗧𝗘, Machine Learning Engineering. I've put that the snapshot of the book cover in order you recognize that, right? And the most useful resource that I still use is this GitHub list. So if you search on GitHub about awesome MLOps or production machine learning, then you'll find a README file if I may. There are like this is a very common terminology. Awesome. That if you write awesome React.js or awesome deep learning or awesome whatever, you'll definitely find a README file including all the different resources, different articles, different video links and course links on that whole GitHub list. Right. So these are the two main lists that I would prefer in order to learn about this field. So you can search it out: awesome MLOps and production machine learning. Right. So yeah, I think that was it from my side, my monologue, and I would like to have questions. I uh, like planned it out like that only, where I spend less time in talking about what I know and more time for questions, if you have any, in order to like answer those in a better way, so that we have a conversation, right? So yep. Snehal, are you there? Or I'm reading out the comments.
Yes, you can see the questions at the bottom of the screen.
Yeah.
Okay, so first
Okay.
question is from Akshat Kumar. So he was
Yeah.
asking about the loop.
Mhm. All right, I'll read that out loud. This loop has to run every time when the data is changed. This must be taking very much time. So yes, I mean, it's not about every time that data change. It's about our strategy, our need, or our use case. In most of the this machine learning systems, this loop runs at a certain interval. Let's say in terms of, let's say if I build a product for a company who wants a demand forecasting system, right? It needs to forecast how much its products are going to sell, right? So there is a specific process, an SNOP, or a process that goes behind the scenes, which takes this demand that is forecasted. It plans, it lays out a strategy to for the manufacturing, for the supply, the whole supply chain. But that process happens at a certain interval, let's say a month, right? So all the data for the sales of that product comes in at a certain interval, and according to our specific use case. So let's say if my supply chain planning or that manufacturing planning happens once a month, so I don't need to run that loop again and again whenever I receive that data. I can accumulate that data, and I can plan a date where I need to retrain my model or generate the next forecast using the latest data. So it totally depends on the use case that we have. There are some models which never needs a retraining, which needs retraining in once a year, or there are live models which requires training, let's say every hour as well. So it depends on the use case. Hmm. Is there any other question? Hmm. Okay, how you can? All right, I missed that question. Can you? Okay, I can see a question from Jeet Singh. Is it compulsory to first learn DevOps, then move to MLOps? Mm, Not necessarily, but as I've mentioned in the slides, MLOps is like heavily inspired from the concept called DevOps, right? So you have multiple, you have most of the things that are common between DevOps and MLOps. So if you have a better understanding of DevOps first, then you can build your knowledge on top of it that is specific to machine learning. So that way you can have a structured learning approach towards learning MLOps. You first learn DevOps and then MLOps. But yeah, definitely it's not compulsory to first learn DevOps and then move to MLOps. You can directly grasp all the knowledge that is on MLOps, and that way you'll cover most of the topics for DevOps as well. I hope that answer your question. How you can do all this in less time? Okay, so this is from Abhishek Gowda. It's okay to do this in less time. There are two approaches to do it. One is the structure or that process that you set up. So if you have that whole learning loop structurized, then it will take less manual intervention, so that way it automatically becomes fast. That's from a process standpoint. To structure the whole thing in an automation fashion, we like if we do automation at each of those parts, we can reduce the time by a lot. Many of the companies that struggle nowadays, that requires more time in order to do all this, that requires more time basically, is due to that unstructuredness of this whole process. There are a lot of manual intervention that is getting done, which increases the time, right? So that's from a process standpoint. If we structure it, if we automate this whole process efficiently, do all the engineering correctly, then we can reduce the time. But if we have that process set up, and now if we want to let's say reduce the time even further, then we need to weigh it with the budget that we have, right? So we can parallelize that whole training process. So let's say there are 1,000 models or 1,000 products in a company that needs that demand forecasting. So in order to do this step by step on one single machine, which will definitely cost you less because you're only using one machine, right? We can use beefier machine or a heavy machine, and also put multiple machines. There are frameworks, one of which which I like the most is Kubernetes, which solves this issue, or solves this whole process of training that machine learning model in parallel, using multiple machines, using multiple virtual machines, if I may, and do that quickly. But in that case, the only point is you are incurring more cost, right? So if you want it in less time, then either you need to better your engineering, do that automation correctly and standardize that process, or you use more resources and do the training or this whole loop in parallel, right? So yeah. Pankaj Patel says that I have a good knowledge of deep learning and ML. So is it a good time to start learning MLOps? Okay, so to answer that question, there are two options, right? If you want to call it that way, there are two options that you build that expertise on deep learning and ML, or you entirely shift to MLOps, right? But it seems as an option, but in real world it's not an option, right? If you are building deep learning or ML models, either you become a researcher. Now there you only build those algorithms, do research on improving the accuracy and all the other things. But most of the companies today, later on it might be a different case altogether, but most of the companies in today's world require you to have that understanding of MLOps or that machine learning engineering, right? It's not only about writing the code in Python and then just getting away with it because I'm a data scientist or a deep learning engineer, right? You have to have that basic concept of how the whole process works, so that you can better align to all your colleagues that you're working with. So it's not an option. You will have, at some point in time, you'll have to learn about MLOps or machine learning engineering in general, in order to cope up, right? So you learn deep learning, you learn ML. That's the base for MLOps as well. If you only want to learn about MLOps, then that will also not suffice. You must have a brief understanding about how that machine learning works, how what is hyperparameter tuning, what is that goes behind the scenes for deep learning, right? You must have a basic understanding. Then only you can build around that. Then only you can engineer around that using concepts of MLOps. So it's like, from my perspective, it's just an opinion, but from my perspective, it's not either or, it's both. Just the weight is distributed according to what you want to go for. So to like directly answer your question, yes, that's a good time. Now you have a good understanding of deep learning and ML. Now you will excel in MLOps if you want to learn that. That's a good prerequisite to have. Yep. 𝗗𝗔𝗧𝗘 says, in future, is it possible for you to demonstrate any simple algorithm like logistic regression to train model and to deploy it as well? I was actually planning to have that demonstration in place, showing you some basic tools and frameworks that that a machine learning engineer uses in its daily life, but that could have taken some time, which was injustice to the overall knowledge that the whole set of frameworks and everything else in a generic fashion that I talked about. But yeah, in future, if I have a chance, then I'll definitely demonstrate not only a simple algorithm, but yeah, an algorithm or a system that covers all of these topics, all of these steps in that whole process. So yeah, if I have a chance, I'll definitely do that. And if you are interested, I'll also share my contact details. If you want to connect offline, then we can. I would love to share my knowledge around that, give you a demonstration about how we do it. Yeah. Okay,
Yeah,
it's a
so
compliment. Yeah. Thank you. Thank you, knowledge check. Yeah. Yes, Nehal, go
yes,
ahead.
we have one more question.
Yeah. Shruti says, you said with the help of a forecast about training the data, can it be used for upcoming products of a company that has to be developed with AI? Okay, that's an interesting question, and that's a very great question, actually. So, there is a whole field called generative AI, which I'll talk about this in a different context. Then maybe you can relate it to the question. I'll try to relate it to the question that you have asked. So there is an experimentation that was done, which revolved around a car, let's say a racing car, right? And people or the scientists put up different sensors on that car at different locations, near to the tires, the bonnet, every other joint that the car had, right? And they collected that data, stored it, did the whole loop that we talked about, all the data preparation, the cleaning of it, and building a machine learning model around it. And what that model did is it came up with a new chassis for that car, which was highly optimized according to the data that they've got, right? So it uh, sort of forecasted, or it sort of predicted what kind of design that car should have in order to achieve maximum efficiency, in order to reduce that resistance, or make that car go faster, or whatever limitations or whatever goals that we want to that they wanted to achieve. It came up with the design. So uh, there are multiple algorithms which are there to predict such things like that, which do not exist right now. but most of the type of algorithms are using heavy inspiration from the data of past. So in case of the products, I'll try to relate it to your question. So one is that I talked about forecasting the demand for existing products for future, right? But companies are also using AI in terms of doing new product launches. So let's say they come up with an idea. Okay, I should like try this new shampoo bottle of 250 ml which has this ingredients, right? So they run it through an AI simulation whether that product will gain success or not, whether that product will sell or not. And the way they do it, the way they train that model is use data, that sales data for of the competitor's product. So if there is a similar product to that, to the product that you're trying to launch, then they use the data, train the model which simulates the whole scenario, all the promotions that you need to do, all the marketing that you need to do for that product. If you put in, then it will tell you that whether that product is going to sell in huge quantities or not. So maybe not the whole like product that is going to be developed, but validating your ideas of new product, whether it will sell or not. It also applies in music as well. There are great singers who are using AI to predict whether their new song is going to be liked by a certain target audience or not, right? So it's very similar to that, but not the exact answer you're looking for, I guess. But yeah, definitely would love to connect with you offline in order to discuss more around it if you want. Yeah. Is there any other question,
Yeah.
or
Yeah, so that's it. We don't have any other question.
Mhm.
Yeah.
All right,
So
great.
okay, so guys, if you want to ask any question after this session, you can directly communicate with our speaker Saurabh Yadav on LinkedIn
Hmm.
or other social handles. So thank you very much, Saurabh, for giving the sharing the knowledge which you have. And guys,
Mhm.
we have shared the certificate link in live chat as well as in the description of the video, so you can directly fill up the form for certificate. And the timing is till 12 a.m. today, so don't forget.
Hmm.
Thank you.
Thank you so much, Snail or the Pod Warriors, to have me, and love this session, and also the brilliant question that guys asked. Thank you.
Thank you.